Hello everyone, welcome to another edition of the iOS Lead Essentials podcast. I'm Mike.
And I'm Kyle.
And this week we'll be talking about a somewhat obscure but essential topic in dependency injection methodologies, the composition root.
Right, so we talked about composition root in the dependency injection podcast. It was probably the concept that we got the most questions about.
Exactly. It's somewhat unknown and people had questions. What is it? How can we use it?
Exactly. It's an important pattern, but it's not commonly used. So first question, what is a composition root? The composition root is a centralized place in your application where you instantiate and compose all the modules together.
That's it. We're talking about the creation, the instantiation of your objects, and passing the appropriate dependency in any component that needs one.
And you want to do it as close as possible to the application entry point or main.
Right.
And you don't want any other module depending on main, depending on the composition root. And that's how you decouple your modules. Because if module A needs to instantiate components from module B, A depends on B. But if you create a good abstraction in between these two modules and move instantiation to main, to the composition root, then these components are decoupled. They can be deployed and reused in isolation. They can also be tested in isolation.
Exactly. So this is very important to understand that the composition root and main, they are not referenced by any other module in your codebase.
Or they shouldn't.
Yes, that is better, I guess, right. On the other hand, main and the composition root reference all other modules. And that's because they need to import them so they can create the components. So they can create your classes, your structs, whatever that you have there, and compose your system.
So the composition root is one of the most concrete modules in your application. It's the entry point of your application. So next question. Why do I need a composition root in my iOS app? So centralizing the instantiation and composition of objects in a single place drastically reduces the complexity of managing and developing modules independently.
Right. Well, you need to instantiate somewhere all your classes. And the composition root says it is better to do it in a centralized place. They're going to become more testable. They're going to become more extendable because they can defer the instantiation until later. They don't have to decide right then which modules, which components they should instantiate.
So your modules will depend on better abstractions. They hide implementation details, which means you can also extend your functionalities without changing code all the time. You can add behavior or remove behavior just by composing your system differently. So your system is open, closed, open for extension and closed for modification, which is a good trait of a modular and clean system.
That's exactly right.
So by using a composition root, you can create clean components that communicate through clean and simple abstractions, and you can inject dependencies and replace dependencies or remove dependencies easily from a single centralized place, which also reduces the number of dependencies between modules. So it supports a modular design that can be tested in isolation, developed in isolation, maintained in isolation, reused, replaced, and etc. And that's why you would want a composition root in your iOS application. So next question. If my iOS app components shouldn't create their dependencies, where should I create objects to achieve a clean and modular design? Well, the answer is in a centralized place. If you want to support a modular design, your modules should not depend on too many other modules. Ideally, they should be isolated, decoupled from other modules. And you can only achieve this if your modules don't reference other modules directly.
Mm-hmm.
For example, instantiating concrete types from other modules. So for that to be possible, you move instantiation to another module, to the main module, which is your composition root, where the components are instantiated and composed in a centralized place. Next question. Where is the composition root in my iOS app?
Okay, we have a quote here by Mark Seaman and Steven Van Doyersen's book, Dependency Injection, Principles, Practices, and Patterns. And the authors say, the composition root is located as close as possible to the application's entry point. In most application types, the entry point is the main method. Inside the composition root, you can decide to compose your application manually, that's using pure dependency injection, or to delegate it to a dependency injection container.
Right. So where is the composition root? Well, it should be located as close as possible to the application entry point, or main. And the composition root is not a single class or component. It's just a collection of components that can help you instantiate and manage your object graph. For example, you can use a DI container to help you instantiate your object graph and manage the lifetime of your instances. So if you are instantiating your object graph in the app delegate or the scene delegate, that's your initial composition.
Right.
That's your composition root that boots up the application. And ideally, every time you need to instantiate a new object, you should delegate back to the composition root to do that for you. So that's it. Next question. How can I ensure I'm implementing a composition root correctly in my iOS app?
Okay, so the basic rule is you don't want your modules creating other modules. This is the basic idea that there is just a single module, a centralized place, as we have been saying, that creates other modules, that references and instantiates other modules. So what that means is that it is responsible for the composition of your app.
Right. So if you want to support a modular design, you keep your modules independent or decoupled, and then you create a centralized place, the composition root, that will instantiate and compose the modules, maintaining their isolated nature. So how can you ensure your composition root is fulfilling its job? Well, if you have a centralized place where you instantiate your objects, a module just responsible for the composition from the entry point and throughout the application lifecycle, then you are using a composition root correctly. Now, if you have a module that have references to concrete types of other modules just because it needs to instantiate it, and you need those modules to be decoupled so you can reuse them or test them in isolation, then move the instantiation to your main module, the module that starts your application and manages the instances and the object graph. So next question. Do I need a composition root if I use a DI container?
Yeah.
Well, yes. The DI container will help you instantiate and manage your instances. It will help you compose your system. But that doesn't mean you should access the DI container from anywhere in your modules. Your modules should not depend on main. And the DI container belongs to main. Thus, if your modules reference the DI container directly, you are coupling your modules with the main module, with the composition root. You want the inverse dependency. You want main, the composition root, depending on your modules, not the other way around. That's how you're going to support a modular design.
Exactly. So the DI container should be referenced only in main. Otherwise, you are committing the service locator anti-pattern.
Right. So if a module is accessing a DI container directly to instantiate its dependencies, that's an anti-pattern, service locator. And it's often a global, like service locator.shared.get instance.
Right.
Which means the objects are calling the DI container, the service locator, to get their dependencies, but this happens implicitly. Thus, you need to know that before instantiating that component, you need to set up the DI container. You need to set up the service locator.
Exactly. And implicit dependencies, as we've talked extensively in the Dependency Injection podcast, that's going to make it harder, perhaps impossible, to test your components. And it's going to increase the rigidity of your system. Your system will not be modular.
Exactly. For example, imagine you're trying to test a fit ViewModel that depends on a service to load some data. Ideally, you should pass the service to the ViewModel through constructor injection. Thus, you get compile time guarantees that the ViewModel has all the dependencies it needs to operate. Now, if you have an initializer with no parameters and the ViewModel fetches the service from the service locator directly, then imagine trying to test this ViewModel. You need to set up the service locator, a global reference. So if you're running the test in parallel, you could be mutating the instance at the same time one of the ViewModels is trying to fetch it. And you need to remember to set up your service locator before running the test, and then on teardown, unset the service in the service locator. So every time you access your DI containers directly in your components, that's an anti-pattern. Because ideally, you should pass the dependencies explicitly through the constructor. Thus, you get compile time guarantees about your object composition.
Exactly. It's much safer, and it just improves the design by not doing so.
That's it. And you can still use DI containers, but you only access it from the centralized place where the objects are instantiated and composed together. So next question. Should I apply DI principles to a global static struct used for styling the app with colors, fonts, icons? It will be a nightmare to inject that dependency to every view controller and every view. So is it okay to style my app through global static functions or structs? Or do I need to inject the style to every view controller? Well, you use dependency injection to inject dependencies with behavior, but the style of your app doesn't have behavior. They are static colors, fonts, and icons. Thus, yeah, it's probably fine to just access the static values directly. There's no behavior. There's no logic. Just accessing resources.
So you're saying A, it should not have behavior. B, the data should be immutable. So if there is no mutation and no behavior going on, then that's fine.
Yes, exactly. So it doesn't even need to be a singleton like style.shared. No.
Right. Exactly.
It can be literally static factory methods or static access to immutable resources. No need for references or any complex object structure there.
Exactly. Because basically, this styling then, it becomes a namespace for a bunch of functions or static properties, something like that, that provide the immutable values to the rest of the application. So I agree. It's a context. It's a namespace. There's nothing going on with behavior there that can influence the rest of the system. Nor you need to set it up, nor you can have temporal coupling with a component like this.
There's no threading problems as well because you're just accessing resources and data.
Yes.
You're not mutating anything. There's no behavior. You're just accessing static resources. No problem at all. Now, if you want to style some views differently depending on some conditions, depending on some settings, then it may be the case that you should inject the style depending on the settings. But maybe just to some specific views that need that kind of functionality. So you don't need to do it everywhere. If you're just accessing static resources, you can access them directly. But if you want any kind of behavior, any kind of way of replacing that style easily, then a solution will be to inject the style in views that can have different styles.
Right.
And that's it. So DI, dependency injection, is for components with behavior and dependencies. Next question. I have a main storyboard to start my application. Does that mean that the main storyboard is the composition root of my iOS app? No, the main storyboard is not the composition root. Storyboard is just a component. The composition root is the place where you instantiate all your modules and compose them together. So the composition root will reference your storyboard as part of the instantiation of your application. It needs the user interface that is defined on the main storyboard, thus instantiates it for you and puts up your application, sets up your user interface and loads it on the screen. It just happens that it does it automatically for you if you give some directions in your build configurations, in your info plist. So that's it. Storyboard is not a composition root. So the composition root can decide which storyboard to use at launch time, which usually is the main storyboard. But that doesn't mean the main storyboard is the composition root.
Yeah, and I can see how this might be very confusing because your application just starts up based on a configuration that you've given in a storyboard where you set the name of the module that you want to load, the scene. You have a navigation controller perhaps that embeds all these scenes. I think it's natural to think that, yeah, like the storyboard is responsible for the creation of the whole application. This is the root point of the application. But as you said, these are just settings that can just make easier your life in very, very simple projects.
Yeah, you can use storyboards for dependency injection as well. You can define objects, dependencies in your storyboard, and that will instantiate it and compose your components for you. So you can use the main storyboard that should live in main as part of the composition root, as part of the composition helpers that will instantiate your application. Because the composition root is not a single component. The composition root is just this centralized place.
Yes.
The module where you do all the instantiation and composition. So the main storyboard will probably live there if you have one. But you can also decide not to use a main storyboard and write everything in code in your app delegate or your scene delegate and start your application from there manually. So that's it. Next question. Can I use storyboards for instantiating my view controllers, or should I use only code from the composition root? Yes, you can use storyboards to instantiate your view controllers. No problem. As long as you do it from the composition root, you can maintain modularity in your system. As long as you keep your modules separated, then you're fine. And again, if you want modularity, if you have a monolith and you don't mind about coupling all the components, then maybe it's fine to instantiate your objects directly, like a view controller instantiating the next view controller when you tap on a button or on a cell. That's fine as well if you're happy with a monolith. Now, if you want more maintainable code, smaller classes, testable components, clean components, and good abstractions between them, then we recommend you to strive to move the instantiation to a single place in your application, to a single module. And make sure that other modules do not reference the composition root. They don't know about the concrete types that belong to other modules.
Right.
And storyboards are quite handy for things like late binding. For example, if you want to use the same controller class, but with a different view layout, you can use the same controller class, but instantiate it from a different storyboard with a different layout or view configuration dynamically.
Right, because the decision is being made in runtime.
Yes. And since iOS 13, you can even instantiate your controllers from the storyboard with constructor injection, with compile time guarantees that you are injecting all the dependencies the controller needs. So we have a bunch of tools for using storyboards and still maintaining clean separation between our modules. Next question. Can you give an example of a simple iOS app with a composition root?
Okay. So let's take a very simple example. You want to load a list of books from the network and you want to show them in the screen. So what components would you need to achieve that? Let's say you need a service to fetch the books, and then you need, let's say, a table view to show them, and a controller to host the table view.
Right.
And how would you structure an application like that? Well, one way would be to implicitly instantiate the BooksService in the view controller and update the table view based on the result from the service.
Right. So the controller will create the service in it and also create the table view and the cells. This is the most concrete way
Right.
of structuring this application.
Yes.
Because everything is coupled.
Exactly.
So there's no composition root because the controller and other components will instantiate their dependencies directly.
Yes. And the alternative here is, of course, to, instead of the view controller creating its dependency, the service, we can pass it with constructor injection.
Right. So now the view controller would only communicate with the service, but not create it. So it doesn't even need to depend directly on the concrete type of the service. You could rely on an abstraction, like a simple function or a protocol.
Of course. And then the service would conform to the abstraction.
And also, instead of instantiating the table view directly in the controller or the cells that are going to be used in the table view, you can move the view configuration and layout to nibs or storyboards and instantiate the controller from the storyboard in the composition root.
Exactly. So you end up with self-contained components and good abstractions in place. And this is basically the essence of modularity, because now you can inject to the view controller any book service that you want, or you can style it in any way that you want, because you can pass, as you said, nib storyboards to change the layout.
And you could launch your application, and on the app delegate or the scene delegate, you instantiate the service, you instantiate the view controller from the storyboard, injecting the service into the controller. You set it as the root view controller, and you start the application. It'll be very simple to do. Now, if by tapping on a book cell, you want to go to a detail view controller, you don't need to instantiate the detail view controller inside the view controller, or configure the detail view controller inside the book list view controller. Because if you do so, the book list will depend on the detail view controller dependencies as well. If the detail view controller depends on another service to get more data about the book, the dependencies would cascade throughout the system. You would have to pass this dependency to the book controller just so it can pass to the detail view controller. Not because the book view controller needs it, but because its children needs it. So what do you do instead? You move the instantiation and configuration of the detail view controller to the composition root as well. You can use some kind of delegate or closure callback events. Thus, you can create the detail view controller on demand. So you would end up with something like flows, coordinators, moving away this responsibility from the view controller. So the view controller doesn't need to configure its children.
Exactly. You are deferring the instantiation of other components, and that gives you the freedom. The view controller deferred the instantiation of the book service, deferred the instantiation of the detailed view controller. How did it do it? By having abstractions in place, by having callbacks and delegating to someone else. And that's what maintains them as testable, as self-contained, with the minimum amount of dependencies.
That's it. Next question. I work on a large code base with hundreds of components to instantiate in the composition root. Wouldn't it negatively impact memory usage if I instantiate everything up front? Yes, it would. But you don't need to instantiate everything up front. It's not because you have a single place where you instantiate your application that you need to instantiate everything up front. No, you instantiate things on demand. There are a bunch of patterns for that. For example, you can use adapters, coordinators, flows, delegate, observers, events, callbacks, lazy proxy, and etc. So you don't want to, and you don't need to instantiate everything up front in the composition root. You can delay it. You do things lazily, on demand. Next question. Is the composition root testable? Or how can I test the composition root? Yes, it is testable. It is just code.
Right.
If there's code, you can test it. So there are different strategies for testing your app composition. For example, black box UI testing is a strategy. So you can validate the behavior through the UI, which proves that your composition works. The problem is that that's slow and flaky. You need to boot the application, press buttons, wait for animations, wait for services. That can take a lot of time. So that's a costly strategy.
Yes, it's a very expensive strategy since you have to actually run the application. So the more features you have, the more screens you have, the more time it will take. And at some point, it can take that much time that it might become unsustainable.
Even worse if your application is talking to some undeterministic services, like some backend service, which would force your application to run the tests with internet connection, make sure that the external system is in the right state, and also they have connectivity with the backend server. So a different strategy would be to test it with simple unit or integration tests. For example, instantiating your composition and testing the behavior directly by talking to the components and asserting what you expect.
Right.
For example, some side effects or some responses without even running the app. You can just instantiate your composition and interact with it directly with unit or integration tests. So yes, composition root is testable. Next question. Do I need a composition root for a simple app with just a couple of screens? Well, if you believe your application will grow, or if you care about modularity, testability, maintainability, then yes, even if it's a small app, you can instantiate your object graph from a centralized place, from the composition root.
Exactly. A couple of screens doesn't mean the app is not complex, or it will not evolve into a complex application. So it's one of those that you want to be ready so you don't have to get ready.
Yeah, it's better to do it from the beginning than to refactor a monolith into a modular design. If you start with good principles from the beginning, it'll be easy to maintain in the long term. So if your application is simple, that means that it'll be simple to add a composition root. So do it when it's simple. Do it when it's easy. So when it becomes hard, you're ready. Next question. If the composition root is not a single component, how many classes or structs make up the composition root?
It depends on the size of your object graph. It depends how many components you have and how you want to compose them all together.
Yes, you can start with one class. For example, you can start composing all your objects in the scene delegate if you have a single view application. And as you start adding more features, more views, more interactions in your application, you can start creating some helpers, some composers to help you compose the application. But all those composers live in the same module in the composition root, in the main module.
And we have a quote from the book Dependency Injection, Principles, Practices, and Patterns. And the authors say, the composition root isn't a method or a class. It's a concept. It can be part of the main method, or it can span multiple classes as long as they all reside in a single module. Separating it into its own method helps to ensure that the composition is consolidated and not otherwise interspersed with subsequent application logic.
That's it. It's not a function or a class or a single component, but also there's no defined number of components. It depends on the case. If you have a very simple application, single view application, a single class should probably be enough. Doing your composition in a scene delegate, for example, the entry point of your scene, might be enough. But if it starts growing, you can create some helpers, some composers to help you grow your application sustainably. And that's it for today. If you want to learn more about dependency injection and how to apply those patterns on iOS, you can watch the Dependency Injection podcast. And if you're looking for more advanced techniques, join us at academy.essentialdeveloper.com.
Let us know your thoughts, your feedback, and your comments, and we'll see you all next time. Bye, y'all.
See ya.